Hey guys, welcome back. Today we're going to do section 3.3. We're going to be looking at three different types of formulas. We're going to be looking at double angle, power reducing, and half angle formulas. So double angle formulas is where we're just looking at our angles and we want to be able to double them. So how could we find them? So one thing that I would do for this lesson is because the examples spread out, if you want to take pictures of the formulas, so as we go through lessons, you don't have to flip back, or if you want to go ahead, write them down on a note card, it's completely up to you. But let's get started. We're going to do double angle formulas first. So as you can see, we have one for sine. We got three different ones we can use for cosine. And then we have one for tangent. So in this first example, we're going to use the information given to us. And then we're going to find the double angle for sine, cosine, tangent. So first thing I want to do is I want to look and see what we have going on here. So notice we are in quadrant 2. So I want to go ahead and draw this. Okay, remember our angle always comes out from the origin and then down. And then this right here is your alpha. Oops, sorry, this one's not alpha, this one's theta. Okay, so we are given sine. Remember that that is y over r. So that means we're going to have a 12 and then we're going to have a 13. Okay, so that means we need to figure out what this x is right here. So we can use our Pythagorean theorem. Remember, I used the one with the x's, y's, and r's. So x squared plus y squared equals r squared. So we're going to have 144 equals 169. Subtract the 144 from both sides, and we get 25. Now, when I go to square root that on both sides, we get a 5. Now, this is the part where you have to remember you are in quadrant 2. In quadrant 2, x's are negative. So we got to make that a negative 5. Okay. Okay, so let's see what we got here. The first one we're going to do is sine. So I'm going to write that off here on the side. And I'm going to go ahead and write the formula for this one. So sine of 2 times theta is equal to 2 times sine of theta cosine of theta. So we're going to have 2. Well, we already know what sine is. That's 12 times 13. Okay. And then cosine, though. So cosine, remember that's x over r. So that's going to be negative 5 over 13. So let's see what we got here. So nothing cancels. So what's 12 times negative 5? And then you double that. So that will give us negative 120 all over 169. And that would be our answer for double theta. Okay. Let's go to cosine. So we're going to have cosine of 2 theta. It doesn't really matter which one we do. Let's go ahead and go with the second one. So we have 2 cosine squared theta minus 1. Let's see what we got here. So we got 2. We already know that cosine is that negative 5 over 13. I'm going to square that minus 1. So that means we're going to have 2 times 25 times 169 minus 1. That means the top is now going to be 50. And remember, we have to have the same denominator. So I can really just change this to 169. over 169. And then I can just go ahead and take my answer this way. 50 minus 169 will give you the negative 119 over 169. Okay. And the last one, we'll look at tangent. So for tangent, we're going to have 2 times tan of theta over 1 minus tangent squared of theta. We'll just go ahead and go this way right now on this one. So we're going to have 2 times, let's see what we got here. So tangent is y over x or sine over cosine, whichever way you want to look at that. So that means ours is going to be negative 12 over 5. And then we're going to have 1 minus negative 12 over 5 squared. So here we're going to have negative 24 over 5 over 1 minus, what would that be? 144 over 25. And I'll just go ahead and rewrite the top. And then kind of like we did just a second ago with the 169 up here, we're going to make this 25 over 25 minus 144 over 25. And then we're going to bring that down here. And then 25 minus the 144 is a negative 119 over 25. And then we're going to multiply by that reciprocal, which to the bottom we do to the top. So 2 2 negatives will make a positive, sorry. And then we know that 5 will go into 25 5 times. So 24 times 5 is 120. And then that will be over 119. Okay. Okay, let's see what we have next. Okay, so now we're going to take those and see if we can verify. So remember, we typically take the more complicated side to see if we can make it match the more simple side. Okay. So let's see what we have here. So we probably want to work with the 2 cotan of theta over 1 plus cotan of theta. Now, one thing I want to make a quick note of is what is sine of 2 theta. So remember that is 2 sine theta cosine of theta. Okay. But we are going to work with this side right here. So let's see what we can change. So I know that we can change our cotan and this cotan. Okay. Oops, actually meant to highlight the whole thing. 1 plus cotan. Okay, so let's see what we have. Oops. So we are going to take this. So we're going to have 2. And then cotan changes to cosine over sine all over. And then 1 plus cotan is secant squared. Okay, but we can actually rewrite this. So we are going to have, we'll just go this way, 2 cosine theta over sine theta. And this changes to 1 over sine theta. Okay, so just like before, we got to multiply by the reciprocal in the denominator. What you do to the bottom. Oops, I forgot my squared. You guys were probably yelling at me. There we go. What we do to the bottom, we do to the top. So these are gone. One side cancels with one sine, and notice that we have left 2 cosine theta sine theta. So we got it. They match. Okay. Okay, let's go look at B. Probably want to do this side. Let's see what we can do here. So we got a double angle. So we need to change this. Okay. So in looking at this, let's see what we got going on. So we have a cosine squared on bottom. So let's scroll back up here. Because we have 3 of these to get. So remember, we have cosine 2x over cosine squared x. And remember, our goal is to get 1 minus tan. So which one should we try to use? Hopefully you guessed it. And the easiest one that I can see is this first one. Okay. So we're going to get cosine squared x minus sine squared x. And then we're going to leave this. Oops. Okay, I'm hoping that you can see it, but we're going to break this up into 2 separate fractions. Cosine squared divided by cosine squared is 1, minus, and then this right here. Changes to tangent squared. And there we go. We got it. Okay. So again, it looks like we have a cosine double angle, but we also have a sine double angle. So we might have to be looking at changing 2 of these now. So let's see. Okay. Go ahead and highlight that one in green. Highlight this one in blue. So I'm just going to unbox it. We're coming over here with it. So we're going to have 1 plus. Don't know what I want to use yet. And then this is going to be 2 sine x cosine x. Okay, so remember we're trying to get to cotan. And I'm just going to write this off on the side in case you forgot. Cotan is cosine of x over sine of x. So, so let's go back up and see. So I'm going to erase this. No, I think I want to go with the last one on this one. Let's try the last one. Left my 2 off. So let's see what we get. We'll go this way with it. So plus sign doesn't change anything. So 1 plus 1 is 2 minus 2 sine squared x over 2 sine x cosine of x equals, well, we have 2 2's on top, so let's distribute those out, factor those out. So we're going to get 1 minus sine squared x all over 2 sine of x cosine of x. Hopefully you can see right here that is cosine squared x all over 2 sine x cosine of x. So 2's cancel, a cosine cancels, and we're left with cosine of x over sine of x, which gives you cotan. Okay. Okie dokie. I think that's it for that one. Now we're going to go look at power reducing formulas. So if we have sine squared of theta, we can reduce the power down so that we have no more powers greater than 1. Okay. So that's actually what we're going to do here first. We are going to basically reduce these down so where all of our powers are 1. So some of our answers might look okay. Some of our answers might look a little hectic. But the thing is basically to have only powers of 1. So let's see what we got. So on this first one, we can see that we have a sine squared. We also have a cosine squared. So we're going to change these. So we're going to have 8 and then we're going to change it to that up there. So 1 minus cosine 2 times theta over 2. And then the next one is 1 plus cosine 2 theta all over 2. Okay, so we know 2 times 2 is 4, and 4 goes into 8 2 times. So we're going to have a 2, and then we're left with 1 minus cosine 2 theta, 1 plus cosine of 2 theta. Okay, so notice that this is a difference of squares. I'll write it in orange right here. So we know that a minus b times a plus b equals a squared minus b squared. So we're going to change it. So this one is going to be 2, and then I'll just write it in orange. 1 squared is 1 minus, and then cosine squared is basically cosine squared. So we're going to have cosine squared of 2 theta. Okay. So looks like we're going to have to substitute again. So it's going to be 1 minus, and we're going to have to change this. Now we are going to have to be careful because that is 2 theta and not just theta this time. So we are going to have 1 plus, I guess I could put that in parentheses right here, cosine. And remember, it's 2 times theta. Well, our theta is 2 theta. All over 2. And then I can close it with a big one. Okay. You can look at this a couple different ways, but let's just go ahead and distribute. So this is going to be a 2. And then minus, well, when I distribute the 2 to here, it's going to cancel with this 2. So we're just going to have minus 1 plus cosine of 4 theta. Well, if we distribute the negative, we get negative 1 minus cosine 4 theta, and 2 minus 1 is 1. Okay, so we have no powers bigger than 1, so we're done. Okay, sorry, I had to go drink a coffee. Okay, so let's go look at the next one. So we have a cosine to the 4th. So this could actually be changed to 2, or 2, oh my gosh, 10 cosine squared x times cosine squared x. So now we're going to have 10. I'll write that one in blue. I'll write that one in green. 1 plus cosine of 2 theta over 2. And this one is, again, 1 plus. I don't know why my pen's acting up. Okay, so let's see what we got. So we know 2 times 2 is 4. 4 can't divide evenly into 10, so I'm going to just change that as 10 fourths. So the 2's are gone, so I'm just going to drop it. So we got 1 plus cosine 2 theta, and then 1 plus cosine of 2 theta. Okay, so let's multiply this out and see what we get. So 1 times 1 is 1. 1 times cosine 2 theta is cosine 2 theta. Cosine 2 theta times 1 is also cosine of 2 theta. So that means we have 2 of those. And then, of course, cosine 2 theta times cosine of 2 theta is cosine squared of 2 theta. So it looks like we're going to have to change this one. So we're going to have 10 fourths, 1 plus 2 cosine 2 theta plus 1 plus cosine. And we already know what that's going to be. It's going to be 4 theta all over 2. Probably make that one a little bit bigger. Close that. I know it's a little messy, but here's our answer. all of our powers are 1. Okay, let's go to the next one. So on the next one, we're going to go ahead and go with our half angle formulas. Notice here, there's pluses and minuses in them, because the pluses and minuses actually depends on what quadrant you're in. So you will have to pay attention to what quadrant you are. And so the first thing we're going to practice is just practicing the formulas. Okay. So notice that sine and cosine is very close. The first one's a minus, the second one's a plus. But then when you actually do the tan one, it's a lot easier to come use this one in the back. And that's what we're going to do on almost all of our problems. So let's go look and see what we got. So we have to use the figure to find the exact value of all of these. So the first thing we need to do is figure out our hypotenuse, whichever way you want to look at it. I'm hoping by now you might know what number that is. I know we've probably come across this one before because it is a Pythagorean triple. But we're going to go ahead and work it out. So I think I can squeeze it over here. So 7 squared plus 24 squared equals r squared. This is a 49 plus a 576. Add those together, you get 625. And you square root that, and you get a 25. Okay. So I am going to go ahead and write the formula right here next to this one. So that is 1 minus cosine of alpha over 2. Okay. For this problem, we're just going to assume we're in quadrant 1. Okay. So let's go plug everything in. Okay, so we're going to have 1 minus cosine of alpha. So cosine of alpha is whichever way you want to look at it. X over R, adjacent over hypotenuse, but we should get 24 over 25. And all of this is divisible by 2. So remember, we talked about whatever that denominator is, you can change that to be the 1. So that's going to be 25 over 25 minus 24 over 25 divided by 2. So that means we get 1 over 25, and that's divisible by 2. On some of these problems, it's going to be easier for you guys to, I'm going to rewrite it for this one, but this is actually just 1/25 times a half. So kind of like the old school keep, change, flip, so that you can see that this changes to 1 over 50. Okay, now you do have to take the square root of this. So I don't know what all calculators you have or where you're at on simplifying, but the square root of 1 is 1. And notice what I wrote here. 25 is the perfect square that goes into 50. The square root of 25 is 5, and we're left with the square root of 2. Now, you do have to rationalize that denominator. It means you can't have that square root, so we're going to multiply by it. What you do to the bottom, you do to the top. So 1 times the square root of 2 is the square root of 2. Square root of 2 times square root of 2 is square root of 4, but the square root of 4 is 2, and 2 times 5 is 10. So this is the answer that we would get for half of alpha. For sine, half of alpha. Okay, so now let's go look at the cosine one. So I'm going to do the same thing. I'm going to write the formula right next to it. Okay, now remember the only difference between these is this one's a plus sign. Okay. So this time we're going to have 1 plus 24 over 25. We already talked about that 1 can change to 25 over 25 plus 24 over 25, which means that gives us, we'll go ahead and do it. 49 over 25, that needs to be a bigger square root, divided by 2. Remember that changes to 49 over 25 times a half, which gives us 49 over 50. Square root of 49 is 7, and we already know what the square root of 50 is. We did it up top, so that's 5 square root of 2. We treat it just like the other one, so we have to multiply by the square root of 2. What you do to the bottom, you do to the top. So we get 7 square root of 2, and we already know that the bottom gives us a 10. Okay. The half angle for tan. We know that this one is sine of alpha over 1 plus cosine of alpha. So that's going to be equal to, I don't think we've done sine yet, so sine would be opposite over hypotenuse, so 7 over 25 over 1 plus 24 over 25. We actually just did that, so I'm going to go ahead and write the answer to that. So 7 over 25 is going to be, the bottom is going to be 49 over 25. Okay, and we're going to multiply by that reciprocal. Just go ahead and do it this way on this one. Those cancel, those cancel. We know the 25s cancel. We know that 7 goes into 49 7 times. So we're left with 1/7. Okay. Okay, let's go see what we have next. Oh, so we're going to use the half angles to find the exact value of the expression. So use a half angle to help us figure this out. Okay, so let's just go jot down a couple of things here. So as of right now, this is in quadrant 1. Okay, so if we're using the half angle formula, let's go backwards from that. Okay, what is 2 times 22.5? Hopefully you said 45. So I want you to think of the problem as cosine of 45 divided by 2. Okay, so a couple different things here I want you to think of. Okay, first, 45 degrees is your alpha. 45, we are still in quadrant 1, so everything is still good. So I'm going to write the formula. Okay, so it was the square root of 1 plus cosine of alpha divided by 2. So that means we have 1 plus cosine 45 over 2. Hopefully you memorized everything like I've been trying to tell you. So cosine of 45, that's your middle finger. So that is, and it's the top 2 fingers to the left. So we're going to have 1 plus square root of 2 over 2 divided by 2. Okay. We can make that 1 like we've been doing. I'm going to go ahead and change it right here to 2 over 2. So we're going to get 2 plus the square root of 2 over 2. Then remember, dividing by 2 is the same thing as multiplying by a half. Okay, so and that's all underneath the radical, sorry. And so that means we're going to get 2 plus the square root of 2. 2 times 2 is 4. And then we can separate it. This is 2 plus the square root of 2 underneath the radical, but the square root of 4 is 2. And there you go. There's our answer. Okay, let's go look at the next one. So the next one is sine. Okay, so sine, let's think about this. So we're in quadrant 2. Sine is going to be positive. Okay. I don't know how to find the sine of 105. However, what is 2 times 105? So if you multiply that, we get 210. So that means I can change the problem to be sine of 210 over 2. Okay. So let's think about some things here. 210, though, is actually quadrant 3 now. Okay. What would our reference angle be? So 210 is 30 past 180. So it's 30 degrees. Okay. And our 210 is also our alpha now. So I'm going to write down the formula. So remember, sine is the 1 minus. So 1 minus cosine of alpha divided by 2. So we're going to have 1 minus the cosine. And remember, our alpha is 210. So I'm going to go ahead and write 210 over 2. Okay, so 210 we said had a reference of 30. So you should be folding down your ring finger. Cosine is to the left of that finger. So we have 3 fingers. So it's going to be minus the square root of 3 over 2. Now, we're in quadrant 3. And sine is actually negative in quadrant 3. So I'm going to add another negative right there. Divided by 2. So 2 negatives make a positive. Just like the one before, I'm changing this to 2 over 2. So this is going to change to 2 plus the square root of 3 over 2. And instead of dividing by 2, I'm going to go ahead and just change it to multiplying by a half. So we're going to get the square root of 2 plus the square root of 3. And then 2 times 2 is 4. We can't take the square root of the top, so we're going to leave it all over 2, because the square root of 4 is 2. Okay. Okay, let's look at tangent. Okay. Okay, so 255, this is originally in quadrant 3. Quadrant 3 tangent is actually positive. Okay, just things we're trying to keep in mind. So let's go ahead and double this. Okay, if we double that, we get 510. And that's okay. Now, let's think about 510. Okay, I think I'm going to write in green for this one. So 510 is over 360. So we're going to do 510 minus 360. That means we are actually sitting at 150 degrees. Okay, 150 degrees is quadrant 2. And the reference, so that is 30 degrees back from 180, is 30. Okay, so you can look at this a couple different ways. You can look at everything that we just did and leave alpha as 510 because technically it's 510. However, what I also need you to know is that we're technically finding sine of 150 because these are coterminal angles. So I'm going to go write the formula first. Okay, and I think what I want to do is to stay with repetitiveness. I'm going to refer to this as alpha. Okay, so we're going to have sine of 510 over 1 plus cosine of 510. But I need you to go back to everything that I just wrote up here. 510 is coterminal with 150. Okay, so I'm focusing on that. So that is a 30-degree reference. So my ring finger is going back down. So that means, I'm going to write in green right now, that sine is going to be a half because sine is to the right of my ring finger. Okay, over 1 plus, now cosine is to the upper part of that. So that's going to be the square root of 3 over 2. However, we're in quadrant 2 and cosine is negative, so I have to throw a negative 1 in. So that means we're going to have 1 half divided by, remember 1 changes to 2 over 2. So 2 plus and a negative make a negative divided by 2. Okay, so that means we're going to have 1 half, and if you think of it as keep, change, flip, we are going to multiply by 2 over 2 minus the square root of 3. 2's cancel. So we're going to have 1 over 2 minus the square root of 3. Remember, we have to multiply by the conjugate. So we're going to get 2 plus the square root of 3 on top over, now 2 times 2 is 4. 2 times square root of 3 is positive 2 square root of 3. 2 times negative square root of 3 is negative 2 square root of 3. And then square root of 3 times square root of 3 is just 3. So 4 minus 1, or 4 minus 3 is 1. Okay, so that means our answer is just 2 plus the square root of 3. Okay, and please know that you're more welcome to check these with your calculator, and you can see if you get them right. Okay, let's go to the next page. Okay, so again, we're given certain information and we have to find the exact value. So again, let's draw this. So looking at this information right here, this is telling us that we are in quadrant 2. Because we know that this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we know that this is where we are at. Okay, now secant might be confusing, so you can flip it to cosine of alpha, which means this would just be negative 1 over 3. So that means this is going to be negative 1 here, and this is going to be a 3 here. So we will need to do Pythagorean theorem to figure out what our y is right here. So we're going to have negative 1 squared plus y squared equals 3 squared. 1 plus y squared equals 9. Subtract the 1, you get an 8. Now when you go to square root both sides, okay, you will get 2 square root of 2, and sine is positive slash y is positive in quadrant 2, so we're good. So let's start off with sine. Okay, you might be getting some of it memorized by now, but I think I'll just stay all in blue. Oops. The formula here is 1 minus cosine of alpha over 2 which equals 1 minus cosine is -1/3 divided by 2. So we know that this is going to change to 3/3. Two negatives make a positive, so we are going to get 4/3. And remember, dividing by 2 is the same thing as multiplying by a half. So 2 goes into 4 twice. So it looks like we are going to have the square root of 2/3. We take the square root of both of those. Nothing comes out pretty. But it does allow us to rationalize that denominator by multiplying top and bottom by square root of 3. So we're going to get square root of 6 on top divided by 3. Okay. Next, we're going to do cosine. So remember, cosine is pretty much the same exact thing, but instead of a minus, we have a positive. So we're going to have cosine of alpha divided by 2, square root 1 plus cosine of alpha divided by 2, 1 plus -1/3 divided by 2. Again, we're going to change that to 3/3. So 3 plus -1 is a 2. So we're going to have 2/3, changing our dividing by 2 to a half. And 2's cancel. So we get square root of 1/3. I hope you are screaming at me and telling me that the answer is square root of 3/3. But if not, let's go do the math in between. This changes to 1 over square root of 3. Remember, we can't have that. We have to rationalize the denominator, which gives us the answer right there. Okay, that is why I did that unit circle additional lesson, because I really wanted to make sure that it was clicking, because I knew how helpful it would be. Okay, tangent is equal to sine of alpha over 1 plus cosine of alpha. So sine is a little bit different. So that looks like it's going to be square root of 2 square root of 2/3. Over 1 plus cosine, we already know what that is -1/3. So we're going to have 2 over the square root of 2/3 divided by, we already know what this is, it's 2/3. Okay, on this one, I'm just going to go ahead and flip it. So notice what happens. 3's canceled, 2's cancel. We are left with just the square root of 2. Okay. Okay. So it looks like we have our last page now, but it looks like I am missing something that didn't print. I think this should be a 1 right there. Okay, so it looks like that fixes it. So what should we do? By the way, I do want to add that this stuff does come in handy for you guys who are going to go to Calc 2. Okay, it will help with trig substitution. Okay, or you can even think about it as just makes your life easier. Okay, but we're going to verify again with these identities. And I actually really like these. I just think of them as little logic puzzles, so I actually enjoy that we get to do these. So let's see if we can come up with that half angle identity. However, notice that that says cosine squared on it. So we might have to also look at it a little bit different. So the first thing I would like to do is I want to change my secants right here. Okay. Now, in doing so, I'm actually going to go ahead and fix my 1. So we are going to have 1 over cosine plus, and I want to go ahead and change that to cosine over cosine, then 2 times 1 over cosine. Okay, so I'll go this way. So that means we get 1 plus cosine of theta over cosine all over 2 times cosine. Okay, so because the way this one's set up, I'm going to go ahead and multiply by the reciprocal and just show that. So we know these cancel, these cancel, these cancel. And let me see if I can zoom out a little bit. And this is going to equal 1 plus cosine of theta over 2. And we're actually done, okay? And this is the reason why. Because cosine of that half angle is equal to 1 plus, or the square root of 1 plus cosine of theta over 2. So we were asked to find cosine squared. So basically, we squared both sides, and then these end up canceling out. So we are actually good over here. Okay. Okay, looks like B is missing my alpha. I think so. Right here should be a small alpha. Okay. So I think what I would like to do here, because we want to get twice the tangent, let's fix our Pythagorean theorem identity, which is this part right here. And let's see what that does for us. So we're going to have, let's go underneath in case I run out of room. Sine squared alpha plus, oops, let's change it to green. Sine squared alpha all over sine of alpha 1 plus cosine of alpha. So we know that this is going to be 2 sine squared alpha over sine alpha 1 plus cosine, alpha. This sign is going to cancel with that sign. So we're going to get 2 sine alpha over 1 plus cosine of alpha. And we are done. Okay. So we are done because tangent of alpha over 2 is equal to sine of alpha over 1 plus cosine of alpha. Okay. So if I go and multiply this one by 2 and I multiply this one by 2, this is exactly what I would get. So we're done. Okay, we got one more. Oh, and looks like I'm missing an X on this one. Okay. I think I want to actually take a little bit of an easier way out. I think I want to do this side. So we have 1 over tangent of X divided by 2. And then we're going to change this. So I think I'll go this way. So we're going to have 1 over sine of X over 1 plus cosine of x. And then you multiply by the reciprocal to get it out of the denominator. 2 to the bottom, 2 to the top. Those cancel, and 1 times that is just 1 plus cosine of x all over sine of x. So they match. Okay, let me know if you guys need anything.